fault tolerance. And this distributed file system will provide a platform over which other systems like libraries and big table operate. So distributed file system comprises of a single namespace for the entire cluster. Namespace is uniform. For example, when you are taking the names of a file within the file, that is all uniform, irrespective of where it is stored. So there is a simple namespace concept which is given by the distributed file system for the cluster of machine, or that is a network of machines. So here also it ensures the data coherency. That is, you can write once and read many accesses model. So client can only append to the existing files. You cannot modify, cannot update the files, cannot update the data on the existing files. So these are the norms called data coherency, and the files are broken into the blocks. Typically is 128 megabytes, and each block is replicated on multiple data nodes. And this will be having an intelligent client. Client can find the location of the blocks. Client accesses data directly from the data node. So these details we are going to cover quickly today, but in more detail in the other lectures. So HDFS, if you see as per the architecture is concerned, it is having the name node, and there is secondary copy of that name node is there. So whenever a client gives a file name, so it goes to the name node, and name node will knows that that file that is called block ID and data nodes, where that block and which data node it is stored. This information is given to the client, so that client can directly go and read the file. So name node and storage, and the secondary node contains all the information over the data nodes. And this mapping file to file IDs and list of map nodes is done by the name node. Data node contains maps a block ID to physical location of the disk. So this is the architecture wherein the name node deals with the metadata, that is the name, what are the replicas, where all that stored on which data nodes. So this complete information is stored in the name node, and the client has to client doesn't know directly where the files data is stored on which node. For that, it has to consult the name node, and name node provides the complete link, and that client will use that link for reading and writing into those data nodes. So by the problem of counting the numbers of occurrences in each word in a large collection of data, so how do you do it in parallel? Obviously, you require to divide the document among the multiple worker nodes, because if it is too huge, so you require multiple workers to process all that data. So each worker will do all that and partition the word into the counts by each worker, and then it will be aggregated in the end. So this can be seen working in the MapReduce programming model. So MapReduce programming model is inspired from MapReduce operations commonly used in functional programming languages like Lisp. So it contains an input, which is nothing but a set of key value pairs, and users will has to functions, the map, and the views. So map comprises of the key and the values, and map will emit the list of keys and values, and the user will aggregate for a particular key k1 the list of all the values which is emitted by the map function, and then it will perform the operation on the list based on the programmer says, and it will generate the result. For example, let us say v2. So for key 1, the value will be output will be v2 pair will be emitted. So let us understand this example. So you see that key K1, B1, K2, B2 is all key value pairs. The data or the input you can see in the form of key value pair, and the map will be applied on each key value pair, and so it will generate the intermediate key value pairs. Now these intermediate key value pair will be again given as the input to the reducer, and the reducer will for a particular key, all the list of values it will form the reduce function to generate the final output. This operation you can express using the code that is called the map function, and the reduce operation you can specify with the reduce function that is mentioned over here. Now this entire execution environment is of a MapReduce is shown in this particular picture, highly dependent upon the working of the SDFS file system. So to understand the MapReduce, you have to correlate it with how the SDFS also is used together, SDFS and MapReduce, then only you can understand the entire working of MapReduce in that flow. For example, the data, input data from the distributed file system uh, uh, will assign, the master will assign the map function, that means to the worker nodes. So worker nodes is a process, and that will take the split. So the split, the data is not moved, rather worker will be performing its execution wherever those data is there in the form of the split, and a worker will be performing the map function, and it will generate the intermediate key and the list of values by the worker, and it will be written in the local disk uh, that is in the form of S. And then this supple and short stage will be performed on the intermediate data, intermediate results, and this will be given as the input to the worker, and it will generate the output of this form. So MapReduce is widely used for parallel processing. In many of the companies like Google, Yahoo is widely using it. The name of the Yahoo is changed to Hortonworks. Is a major database company now, uh, and they have given the big data stack that we will discuss in this course. And also the example use cases is the Google page rank algorithm on the World Wide Web. So the page rank algorithm is an iterative algorithm that we will discuss how we use MapReduce. You can design or you can implement the page rank algorithm in further classes. And also it also computes the keyword indices in this way and do the data analysis of the web click logs. So database people say that parallel databases have been doing this for decades, and key value storage is a concept of a database, but this particular MapReduce is not only parallel database, but it is more than that. That we will see. So MapReduce people say that we are operating at the scales, that is thousands of machines, uh, uh, involving thousands of machines. So to handle failure seamlessly, we allow the procedural code, the map, and reduce and perform the data of any type. So it's not only parallel databases beyond that. So there are few implementations. So Google has not outside the Google has not disclosed how this MapReduce they are implementing, but the concept was given by the Google and is being adopted by open source community, that is Hadoop, without changing the name itself. So the MapReduce of the Google is quite different than the MapReduce which is used here in the Hadoop because Google has not disclosed complete details. inside Google. So Hadoop is is an open source implementation in Java using DFS, and you have other implementations like Data and several other companies uh, like Facebook and all also use it. So these are the two references. So that I told you that GFS, that is Google File System, is published by the Google Labs, is available, and also the MapReduce is a simplified data processing, and the large cluster is also published and is available. So it's if you want, you can read these papers are good to read and explains you several use cases. So we will in the next class take some of the use cases based on the MapReduce simplified data paradigm. So okay, thank you very much. That is all from my side. If you have any questions, you can ask. Otherwise, we can finish today's class. Yes, a bit, we started a bit late. Any questions?
Is exactly like the code for the mapper and the reducer. So where lies the code of this sort and shuffle fix?
Hello.
Hello, sir. Can you hear me?
Hi, yes, you can speak.
So, like we have shown the code. So in that particular code, it was written for only the mapper and the reducer and the driver part. So suppose we want to make any changes in the code for sort and shuffle. So then for that, what we have to do?
Yeah, this is a tricky question. So shuffle and sort is the intermediate this one results get form of results which is after the map and before the reduce part. So most of the time I haven't discussed about the driver code. So mapper and reducer to to do this parallelization automatically. So this shuffle and short is done automatically. So if you want to tweak into it, then there is a driver code that we will discuss in the next class. Okay. So if there is no other question, we will the next class we are going to discuss use case of MapReduce for k-means clustering algorithms. So k-means clustering algorithms you have already seen in an unsupervised machine learning. But for a big data, we are going to see in the next class how that is all done. And we will also take up another use case which is called a market analysis. How the market analysis can be performed using MapReduce. So these are the few topics we'll discuss in the next class. So thank you all. Thank you very much.